Good afternoon. Thank you. My name is Talbot Jaeger, and I am a spacecraft builder. Success in this industry and craft is everything. You cannot and you're not allowed to fail or have failures. To do that, we work very hard to do design and over-design and analysis and test and retest. And the spacecraft must work. In fact, in the whole process, we make sure we use heritage, and we do it just the way we've done it before. Spacecraft have to have a heritage and been done in a way that we know they'll succeed. Failure is not allowed. However, we know they do fail. In fact, if they fail in low Earth orbit, they eventually decay in orbit, and they come down and they burn up in the atmosphere. If they decay at high altitudes, geosynchronous orbit, they're pushed into the graveyard orbit, a supersync orbit, where they're kept and left for hundreds and thousands of years, and they just stay there. The tombstones do not go along with them, however, but the spacecraft do stay there. And so DARPA put together a program called Phoenix that said, could they put a craft, a robot, into that graveyard area and repurpose, reuse what was up there? A very interesting idea. They named it Phoenix. The challenge to it, of course, was what do you use besides the material there in the robot to repair? What do you bring up to repair, reuse, repurpose these pieces of junk? What tools, what parts, what materials would you even 3D manufacture up there? That's actually not as easy a question to answer as you might think. You might need all of Home Depot to go up and fix and repair what's there. But that's not economical. It's also, you don't know how many hammers or how many pieces of copper. You don't have the right ratios, the right materials. So in doing so, that became a challenge. And what was started was a study to say, given the mix and match of all the things that can be brought up to repair and work on the satellites, how many things do you have to bring? Well, it's not Home Depot. JPL worked and found it's not even 100 or 10, but there's combinations of just 4 things. It's the red up there. It's all on the Pareto front up in the right-hand corner, where large and small fixes are all possible. But there's many different possibilities of these 4 things you pick. So that was interesting enough, but with a little bit further look into the data, even though it was all red, up in that Pareto front, there existed some interesting candidates. Not just combinations of 3 or 2, but combinations of one thing. The one thing, right, to bring into space. Could there be such a thing? Well, I didn't tell you I'm also a biologist and a biochemist. So it looked a lot like a stem cell. These combinations looked like if we could derive the pieces of space like we derive nerve cells from stem cells and liver cells and blood cells and things that are used to being discarded like they are in space and then fixed and repaired or sloughed off, could that system work? So we started to investigate what would it take to make such a space-worthy stem cell. We call it HiSat, this sat-lit, a little piece of a spacecraft that has all the basic DNA of what you need to have in space: power, propulsion, metrology, communication, processing, storage, all those features in this building block cell that using software could differentiate itself upon demand. It could be what it needs to be, build what it needs to build. But it could also be able to adapt and bring about its world to itself and interact with it. In that ability, it would have to be dynamic, because it wouldn't know how it would have to interact or how it would have to be assembled. In fact, it might have to be changing and reassembled. So this dynamic environment also required them to live alone when they were separated. So they had an autonomic system that they would stay alive at all times. And this battle had to work with a sympathetic nervous system, in a sense, communication system, and a parasympathetic system that could enhance behavior or inhibit behavior. And so it could dynamically conform and join and build. Now, I don't have the time to show you all the things that could be done to repair this and how these work. But in essence, Given that you have this stem cell and you can take it into this wealth of the pick your part auto shop, those of you that remember that, okay. What could you do? Well, you could grab all the things up there with these cells, this organism, and you could create an exploration craft, a craft that would be safe, survivable, have longevity, because it would have tremendous redundancy. And when things failed, it could slough off its parts. It's going to repurpose its parts. It can live and breathe and have resilience that you need to go into exploration. This is the beginning of a technology that is the other side of the presentation we had this morning. Instead of diving deep into the micro scale, this is the macro scale of this stem cell idea. And I'm looking forward to see where we go with this technology. Thank you.